Good morning, everyone. Today we are going to solve another problem about how can we draw a shear and bending moment diagram using the equations. So the beam that so what we have here, we have beam, so this is the beam that we have, and we have applied moment equal to 180 kilonewton meter, and also we have the triangular loading. So start from 0 to the maximum value, which is 30 kN per meter. What else we have? We have reaction here, reaction, let's say by, and reaction which is ay. The distance that we have, so from here to there, is 4.5, and from here to this point is 9 meters. As we said, the question is how can we find the shear and bending moment. First of all, we need to find the reactions, which are AY and BY. We can't solve this until we find AY and BY. So we need to take moment, for example, about BY or about AY. So let's take moment about point B equal to the 0. I'm going to assume this direction is positive. So we have the first point, the first reaction, which is AY. I'm going to be rotate like this, which is positive. So AY times distance from this point to this, which is 9 meters. What else we have? We have the moment, which is the same direction of this, so it's going to be the same, plus 180. What else we have? We have this, the load, but this is a triangle. I'm gonna make it as a resultant, which is located here. It should be this R resultant is 30 times 30, this is the height of the triangle, and this is the base, which is 9 divided by 2. 30 times 9 divided by 2, which is equal to 135. Okay, and this resultant is going to be located at a distance equal to third of the 9, which is 3 meters. Correct? So to take moment here, I'm going to say this resultant times the distance, this distance. Okay, so it's going to be minus, because it's opposite. So minus 135 times 3 equal to the 0. From here, AY equal to 25 kilonewton kN. To find BY, I'm going to say motion of Y equal to the 0. We have AY plus BY should be equal 135. So from here, BY equal to 135 minus AY is 25. So BY equal 110 kN. After we found the reactions, we are going to draw the beam, but in this case I'm going to put the reactions. We have 25, we have 110, we have the moment 180, and also the loading. Okay, so to find the shear and bending moment diagram, we take a section here. Let's call it section 1. So we said this one is going to be 30 kN per meter. So section 1 I'm gonna put it somewhere here. Okay, so and this is x, a direction of x. We have 25, we have shear V1, and we have moment M1. Okay, but what we have, this one, if they continue, make the big one, which is this one, 30, but I need this, which is y. I need this y, how much? So from similarity, I'm gonna say 30 from the similarity, I'm gonna say that 30 here divided by this distance, which is how much? 9, sorry, should be equal y, this y, on x. So y equal to 30x on 9. Okay, 30x on 9, that means I have the resultant of this triangle. This is the resultant. Let's say equal R1. So R1 equal to the area of this triangle, which is y, x on 2. We know y is 30x on 9, and we have x on 2. So R1 equal 30x squared on 18. So in this case, what about V1? V1 should be equal minus the R1, correct? Sorry, we're gonna say summation. Fy equal to the 0, we have 25 up minus the resultant, which is 30x squared on 18, minus V1 equal to the 0. So from here, V1 equal 25 minus 13x squared on 18. This is the first one. What about the moment? Moment M1, I'm going to take moment here equal to the 0, which is equal 25 times x minus the resultant times this distance. This distance is third of x. Okay, so I'm going to put it down here. So M1, take summation of moment equal to the 0. So I'm going to say 25, this is 25 times x minus the resultant, which is 30x squared on 18 times third of x equal M1. So M1 equal 25x minus 10 on 18x cubed. 10 on 18x cubed. This is M1. So I'm going to put the table. One table for the moment and x, one table for v and x. So for x equal to the 0, how much v? You see how much v? For x equal to the 0, this is going to be 25. For x equal to the 9, how much is going to be v? I'm going to put, instead of x, 9 squared, so the v is going to be equal to negative 110. For the moment, if x equals 0, moment equal to the 0, this is the moment equations. But for x equal to the 9, moment equal minus 180. We finished the section 1. We have another section, which is here. I'm going to cut here, take this side, the right side. We have just the moment. So I'm going to put this section here. So just we have moment, which is 180. I cut on x direction. This is, we have this is x. Again, we have shear is up, V2, and we have moment is M2. So sigma fy equal to the 0, we're gonna find v2 equal to the 0, and m2 is gonna be minus 180. Okay, kn meter. So let's draw the shear and bending moment diagram. So here, this is section 25, 110, and we have the moment 180. As we said, this is point P, A, B, C. So to draw the shear diagram and moment diagram, so this is for shear. We have, first of all, we have 25. This is 25 up, and this is because at v equal 25 at 0. V equal 110 negative, so it's going to be here. How much? Negative 110, and this one is going to be like this. Why curve? Because this one is a triangle. After that, we have 110 up. That makes my draw going to the 0. But v2 equals to the 0, so this one is going to be continue at 0. This is for shear. What about the moment? So for the moment, I'm going to draw it here. Maybe I'm going to move this all that down another page. Okay. Okay, so we draw the shear. We need the moment, so I'm gonna put the moment here. Again, you remember we have moments at 0, the moment is 0, and at 9, how much the moment was my negative 180. So we have negative, and we have at moment 0 shear. We need, of course, I have maximum moment. How much this maximum moment? I need to find it, and then going down to this one is 180. It's negative 180, and then it's continue to 180 here. Then we have another 180 which is positive, then make it 0. Okay, so this is my drawing for the moment. So how much this value, which is the maximum moment, I need to find the distance from here to there, which is x. Then we can find the moment. How can we find this x? You remember when we cut in this section 1, we found the shear in terms of the x. So let's find it. What is the equation? So this is the equation for the shear. This is the equation for the shear. So we said, so this is the equation for the shear, that shear equal 25 minus 30x squared over 18. So if we copy this, okay, I'm gonna copy it and put it here. So I'm gonna put it here. This is my equation, 25 minus 30x squared over 18. So in this, I need to know how much x if my shear equals 0. So I'm gonna put 0 equal 25 minus 30x squared on 18. Okay, so x equal to 25, okay, times 18 on 30 all square root. So that correct? So it's gonna be 25 times 18 divided, yeah, correct. So x equal to 3.87 meter. Then if this x 3.87, I need to find the moment. So the moment, what is my equation for the moment? I'm gonna find it, which is here. Do you remember? This is my equation. This is the equation for the moment at the section 1, 1. So also I'm gonna copy this equation. I'm gonna copy it. Then we're gonna put it somewhere here. Okay, so this is my moment. I'm gonna just substitute x by 3.87. So I'm gonna say moment equal to 25 times 3.87 minus 10 on 18 times 3.87 cubed. This moment equal to 64.5. So this moment is gonna be 64.5. So this is my solution for this example. Thank you.